Hi, welcome back to another Celltomic video, and today we're going to cover on coordinate geometry. So coordinate geometry is defined as the study of geometry using the coordinate points. And for this part, we're going to look at lines. So when we look at line, we first have to look at the gradient of the line. So the gradient of the line is actually the slope of the line. A line with a positive gradient is one with an upward sloping line. A line with a negative gradient is downward sloping. The formula for the gradient of a line can be defined as y2 minus y1 over x2 minus x1. Now let's look at how we can apply the formula in a graphical method. A positive gradient line is one which is upward sloping, so it looks something like that. And we know that a graph, and we know that a line that is downward sloping looks something like that. So this is negative, this is positive. In coordinate geometry, when we look at lines and we are asked to find if we are asked to find the gradient of the line, they usually will give us 2 points of the line. So let's say we have this point here, and this point is 1, 5. And let's say they give us this point here, and this point is -1, -3. The formula for gradient states that gradient equals to y2 minus y1 over x2 minus x1. Let's say we use these values here to be our x2 and y2 values, and these values here to be our x1 and y1 values. So y2, which is 5, minus y1, which is -3, over x2, which is 1, minus x1, which is -1. And this will give us 8 over 2, or equals to 4. So we have a positive gradient of 4. Let's say in the case of our negative gradient, we're given this point here and this point here. And this point here, for this point at the top, let's say we have the values -2 and 4. And this one here, and the bottom one, we have 1 and -3. So for this gradient, let me continue writing in red. Gradient for this would be, okay, in this case, we let this be our 2 and let this be 1. So y2, which is 4, minus -3 over x2, which is -2, minus 1. So this will give us 7 over -3. So our gradient for this is -7 over 3. So this is a downward sloping curve because it's a negative value. Okay, let's move on to the length of a line segment. So the length of a line segment allows us to find the distance between 2 points. So the formula is as shown: x2 minus x1 square plus y2 minus y1 square, and then you square root the answer. So this is actually derived from the Pythagoras theorem. So let's look at a graphical method again. So let's say we have a line that is a positive gradient, so it's upward sloping. Okay, this line has 2 points. Points A, which is 3, 6, and then point B, which is -2 and -3. For us to find the length of AB, we can imagine this as a triangle. So I'm going to dot it out. Dot A down all the way to reach B, and then from B we're going to dot the other way around. So in order for us to find length AB, we can just find from A to this bottom part here, which is, let's call it X, and from B to X. From A to X, and from B to X. Let's call this lowercase a, and let's call this lowercase b. So AB is actually square is actually equals to a square plus b square, which is actually our Pythagoras theorem formula. So now we just need to find what the values of a and the values of b is. Okay, in order for us to do it, so a is actually equals to x2 minus x1, which is exactly the same as the formula earlier. So it's 3 minus negative 2, and this will give us 5. And b equals to y2 minus y1. So this is equals to 6 minus negative 3, and this is equals to 9. Therefore, AB square equals to 5 square plus 9 square equals to 25 plus 81. So AB equals to square root 106. So that is the length of AB. Okay, now we move on to line equation. So the line equation tells us the equation of the line. Okay, let's assume we have 2 points, point E and point F. And there's a line that's drawn going through E and F. This line E and F can be defined using the line equation y equals to mx plus c. The cool thing about this line equation is that any point on this line, let's say we have this orange point here and we call it B. With the line equation, we are able to find what the points B, we can find the coordinate of point B. And we only can do that if we know the following. So the line equation y equals to mx plus c, y and x represents the y and x coordinates. And they have to be at the same point. I'll show that later. M is the gradient of the line, and we can find the gradient using the formula that we have earlier, which is the gradient equals to y2 minus y1 over x2 minus x1. And last but not least, C. C is the y-intercept. So the y-intercept is actually the point where the graph cuts the y-axis. That is the y-intercept. Let's look at an example here. So in this example, we have the diagram that shows points A, B, and P. The point Q is on the AB line such that PQ is perpendicular to AB. So they tell us that the product of the gradient of PQ times the gradient of AB is -1, and they ask us to find the equation of the line PQ. Okay, first things first, we need to find the line equation of AB. So we need to find line AB. In order for us to find the line AB, we need to have 3 important points. First, we need to have xy value, because with xy value, we are then able to sub it into the equation. Next, we need gradient. And lastly, we need y-intercept. In order for us to have our line equation, we need to have the gradient and y-intercept. Those are the most important things. So, first and foremost, we can find the gradient of line AB as we are given the coordinates of point A and the coordinates of point B. So that is the first thing we can do, gradient. So gradient equals to y2 minus y1 over x2 minus x1. So we're going to let point A be our y2 and x2 values, and point B to be our y1 and x1 values. So from the graph, we can see that the line AB is actually a downward sloping graph. So from this downward sloping graph, we can deduce that our gradient is going to be negative. So y2, which is A, we're going to take 2 minus -4 over -4 minus 8. And this would give us 6 over -12 equals to -0.5. So now we have the gradient, which is -0.5. So we can place a tick here. Okay, next we need to find the y-intercept. So we know that the coordinates A is negative 4, 2. We know that our gradient is negative 0.5. So now we can find the y-intercept. We have the xy value and we have the gradient. What we need to find is just the y-intercept. So we're going to sub all these values into our equation, which is y equals to mx plus c. So y is 2 equals to m, which is our gradient, which is negative 0.5, times x, which is negative 4, plus c. And this is equals to 2 plus c, so c equals to 0. So what this means is that the graph actually cuts the y-intercept. And we can see that from the graph. Okay, so now we know that the coordinates of P is 5, 3, and we are asked to find the equation of line PQ, which is the other line. From the question, we are told that the gradient of line AB, so gradient of line AB times gradient of line PQ equals to minus 1. So with this, we can find the gradient of PQ. So gradient of AB, we all know it's negative 0.5, so let's call it negative half, times, let's call gradient of PQ M, PQ equals to minus 1. So gradient of MPQ is equals to 2. And now we can sub everything into the equation again. So y, which is 3, is equals to m, which is 2, times x, which is 5, plus c, and this is equals to 10 plus c, so c equals to negative 3. Now we're going to sub everything back. Now we're going to sub the gradient and the y-intercept back into y equals to mx plus c to get the equation of the line. So equation of the line PQ is equals to y equals to m, which is 2, x minus 3. And that's how we find the line PQ. So that's all we have for today. I hope that you have learned a thing or two from this coordinate geometry video. Please continue to support us, and you can follow us on our Instagram page, which is Celltomic. And remember to always stay curious.